So welcome. Today we will be talking about using AI and deep learning for vision systems. Our technical expert today is Sean Lett. He is with AIS Technology Group. I am Heather Brose, and I'm with SME, and I will be your moderator today. Before we get started with the questions, I just want to go over a few housekeeping items. We are recording this session. You can use the Q&A window to type in your questions if you have any during the session today. We did receive some in advance, so we will be going through some of those, but we'll be checking that Q&A window throughout the session, so feel free to type in some questions if you have them. We will moderate them and try to give priority to questions that might be asked by multiple people. So if it's a topic that a lot of people are interested in, we will try to get to those questions as early as possible. And we will be accepting questions through until about 12:50 today so that we can get through our last questions before we wrap up by about 1 o'clock. A few more things. At the end of the webinar, when you close out, there's a very brief survey, and we just ask that you take a couple minutes. It probably won't even take you a couple minutes, but if you can complete that and give us some feedback on the session today, it would be great. These sessions are developed to really help you and your business grow, so your feedback helps us improve and continue to offer great topics and keep these sessions coming. So along those lines, if you have suggestions for upcoming topics or if there's a specific expert you'd like to hear from, send us an email at AMAmfg@sme.org, and we will get back to you if we have any questions. And it's just great to get those suggestions from you because, again, this is a series that's for you. So we want to get the answers to the questions that you're really looking for. And so getting started for today, just a little bit about Sean. Sean is a Vision and Automation Sales Manager at AIS Technology Group. He has more than 27 years of experience. He focuses on automated machine vision in automotive, aerospace, consumer product industries. And he really is focused on building a successful application and working with customers to identify the key areas that will impact their business. So with that brief intro, I'm going to open it up. We're going to get started with Sean and asking him about questions on AI and deep learning for vision systems.
Thank you, Heather.
Sean, you're there. Great.
Yeah,
good.
I am.
All right, so we should have you on video. Great. Hi, Sean. How are you?
Yeah, good. Thank you. Thank you for the invite. It's the first time I've ever done this webinar, but I am looking forward to it and should have some fun.
Great. Well, I'm just going to kick it off with our first question, and it is, does AI envision require hundreds or thousands of pictures to be used to make its capability exceed a discerning human eye? And if so, what is the most effective way of generating these pictures?
Okay, so that's a very common question. So, just for clarity, the role that I'm in is we primarily do vision system integration. So we've jumped on this AI deep learning vision bandwagon for a couple of years now. And when I go and talk to customers, it's a common approach when you've explained the concept behind this. And usually what we say is, I mean, it does depend on the application, but usually what we'll try to do is acquire about 100 images of a good part or a good sample set, and then 100 images roughly of defects. And then what we do is we take half of those good images and we put them aside, and we take half of the bad images and we put them aside. And what's left over, we use in specific with the software platform that we do, is we take the good images and we train them. Because you've got to teach the AI or the deep learning software what is a good image. And most importantly with that is understanding the standard variability from one part or one image to another. Where a lot of vision systems have trouble and end up failing to meet their expectation is that they can't handle a lot of variation in the surface or the part themselves. So what they'll normally do is when there's variation in that or randomness, they'll actually do what's called a false failure, which means they'll identify a standard process variable as a defect and fail it. So what we do is we want to get a really good sample set of good images, and we train the system. So then it learns the process variables. And then we take the sample set of the bad images, and we individually go through them and classify, identify what those defects are, and then train the system. So we've trained it on good, and we've trained it on failed images or failed features. And then what we do is we go back to the sample set that we set aside, and we run those for validation. And what we do is we take the sample set of good images that we never trained on, and we run it through the system in emulation. And if we actually pass all those images, then we're off to a good start. If for some reason some of those images fail or go into what's called a gray zone or a confusion zone, we take those aside. Then we take the failed images, we bring them in, we run those through. If we fail accurately on all those images, then the system's set up. But again, if some of those images pass, we then take those gray or those confusion images and we retrain the system on those. So the great thing about deep learning AI is because you're actually using images to train the system, it's iterative, which means you can continually add to it and make it smarter and smarter. So hopefully I've answered your question. And in some instances, yes, it will be a lot more than 100 images. Or it could be less. We've done some applications where we've been able to use 10 images of both pass and fail to be able to reliably do it. So it's you know, I'd like to say up front. Now, the most effective way to do this, or we found to do this, is we'll set up cameras directly on the line or on the machine, and we'll actually acquire those images in normal operation of the machine. You're in the environment, you're seeing how the parts or the web or the product that you're actually acquiring the images on, you're seeing them in real world. So we'll actually acquire all those images. Then we'll sit with the customer and we'll go through those images and we'll classify what is good and what is bad, and then we take them back and run through emulation. So hopefully that's in a long way explained or answered your question.
Thanks, Sean. Our next question is, if multiple software companies are working on AI, how is the consumer to be ensured that the AI chosen will continue to be maintained or serviced for the intended life? Right.
So if I look about this in the round scope of machine vision, and I started this in this industry in '99. Since that time, a lot of companies have come and gone into that space. So if you are looking at a deep learning or AI vision supplier, what you want to do is you want to find a company who is focused 100% of their effort, which means their primary product is machine vision. You want to look for history within those companies. You want to know that they've been around for a long time. Generally speaking, are they public companies? Again, their focus is in machine vision. You know, two companies come to mind, Halcon and Cognex are both companies that meet the criteria. They've been around for a very long time. Both companies focus pretty much 100% of their time on machine vision applications, and both have moved into this deep learning AI space. You know, it's been really decades since there's been any dramatic change within the machine vision space. It first started where you took an image and you binarized the image, which means every pixel was either black and white, and then you applied what's called rule-based vision to it, which means you tried to pick up edges or blobs or features or patterns. Then it moved from binary into grayscale, so every pixel was no longer black or white, it was 0 to 255. 255 being white and 0 being black. And it gave you a lot more resolution and capabilities as far as doing it. And that's, decades since grayscale came out. There's been a lot of improvements in lighting and optics and some tools, but it wasn't until AI started to make its appearance within the machine vision space that, there was a real change and a real dramatic shift in the capabilities. And those two companies, as giving you examples, are both companies that have seen that and have jumped into that space. So again, it's important to make sure that the company you're looking at, there's a lot of startup companies out there. I was at Automate, and a gentleman came up to me and was showing me an application he had on his cell phone, which was able to do random OCR on different types of features. I mean, it was very impressive. It's a smaller company, and the question is how long, do they have the funding and everything else to stay around? But I would stick with companies that are putting millions and millions of dollars into R&D, well trusted, and have a good history in machine vision.
Good. So taking it kind of the next step, what are some of the challenges that companies face when they're trying to implement a vision system with complex parts? The person who submitted this, spoke specifically about cavities and blind holes. So what can you offer along as far as challenges and how to address some of those?
Right. So there's one constant, even in the deep learning AI space, which is vision, which means you have to start with a good image. So it doesn't remove the fact that lighting and optics and getting a good image is still very critical. If you don't have good lighting and optics, you're really going to struggle with being able to do a proper application. As far as challenging, you have to solve. So for this example, as far as I believe it's cavities and holes, you've got to solve the optics solution first, which is how do I actually go in and actually acquire an image. We've done some systems in the past where we actually insert what we call a light pipe with a number of cameras, and we actually go down inside of cylinders to actually acquire 360 degrees around the inside of a cylinder. We acquire those images, we stitch them together, and we unwarp them. And then basically what we've done is we've applied our vision tools or deep learning tools to those as well. So the challenging parts, first and foremost, is solving it through lighting and optics to make sure you can get the image that you need to. Once you've done that, then you can start figuring out which vision tools are going to be appropriate. Heather?
Sorry about that.
Yeah.
So our next question is not specific about AI. It talks a little bit about augmented reality, and they're asking questions about applying AR to CNC machine training. And I know it's not the AI space, but can you kind of help explain the difference between those two for people who may not be as familiar with that?
Yeah. So there's AR, augmented reality, which is generally using some vision or example, Microsoft HoloLens, where you're displaying graphics over real-time images that you're receiving in. We played with that a little bit, and it's generally with regards to adding more information into a space that already exists. The AI deep learning aspect of it is, with regards to machine vision, really is completely separate from augmented reality as far as this topic is concerned. AI and deep learning really is designed to take machine vision, which you'll hear this. If you haven't heard this already, you will hear this as you move into it. the traditional or rules-based vision and AI, which is you're actually, you know, trying to emulate the human brain as much as possible. So much the same way as the common example I use is if you take a small child and you show her, you know, 5 pictures of a home, 5 different homes. There's one commonality with that. There's a roof, there's walls, there's probably a door, there's windows, but you show him or her 4 or 5 images of a house, and then you show her another image, and you ask her what it is. She'll say that's a house, because the brain can take those images and definitions that you've given them and do that. Machine vision is moving into that space, and with AI deep learning, it's able to do that. But as far as augmented reality is concerned, I haven't played in that space as far as defining that, but you know, in this instance, they're 2 completely different environments.
Thanks for that. I think that might be helpful for some people, just understanding the differences there. If we look at cost, which I know is always a factor when you're talking about implementing new technology, what can people expect as a range for setting up these systems and implementing AI and deep learning and really putting this in place for their business?
Right. Great question. It's a common question I get. You know, vision 20 years ago, 25 years ago, was usually the $20,000 to $30,000 range just to buy a vision system from a company. That's without implementing any type of programming or lighting and optics. You know, very, very challenging, and it was also very challenging to use. You had to use a higher level language like C++ or Visual Basic to program the systems. You know, since that time, a lot of companies have figured out to grow their market, they have to make them easier and less expensive. You can buy a vision sensor right now that can do pattern recognition and defect inspection and some rudimentary dimensional gauging, you know, in the $1,000 to $1,500 range. This AI and deep learning is, you know, because it's fairly new and there's still a lot of engineering work that goes into it. You know, the costing of these systems start just for the software in the $15,000 to $30,000 range, just to buy the software. Then you need to apply industrial PCs with high-powered graphics cards, GPUs, to actually run them. So, you know, generally speaking, if I'm looking at a general application, I'll usually start in the neighborhood of, for a complete turnkey, you know, anywhere from $75,000 to $100,000, and that's, you know, supplying all the hardware, the vision, the programming, deploying the system, running the system off, getting the buy-off from the customer, and leaving them with a functional system. So it's not a cheap endeavor to look at AI and deep learning. But again, looking more of a pragmatic approach that I've done. You know, 5 years ago, before AI and deep learning, there were a lot of applications we just simply would walk away from because they were just too challenging. Hopefully you can see this. I cut this off of a sample of a web in the back, so hopefully nobody's going to give me trouble for this. But if you look at this part, generally speaking, it's let's say, for example, it's a web part. You'll see a lot of features and a lot of randomness and variability. Some of the lines that are on it, some of the normal variations with it. And generally speaking, this is one of the most challenging applications when you're looking for, let's say, a defect up at the top here, because you've got a pattern that's changing. It's traditionally what we call noisy. A lot of variabilities to it. There's certain features on here that are acceptable, that what would happen normally is when you set up a traditional vision, it would actually identify some of the normal variations on the surface as failures. So, you know, you're trying to pick up that, and it's actually picking up other certain features on this part. So, you know, back to my original point, a lot of applications struggle mightily because they can't handle the randomness and the variability that you'll see from image to image to image. And, you know, my experience looking at some of these applications, which say, listen, this is just not possible. Now with the deep learning, the AI, we've come around on that. And there's some of these applications where we can now take this part and we can learn all the variability that's on the surface and train the system to understand that it's acceptable. And then we'll take this and we'll identify that this is not acceptable, and we'll train the system to look for this feature or a variation of this to do it. So while they tend to be expensive systems, they tend to solve applications that just haven't been able to be solved in the past. So you know, you're paying for what you get is basically the answer to that.
And when you start talking about like an ROI on that, Sean, you know, you're talking $15,000, $20,000 for just the software portion and kind of getting started. But what have you seen, you know, even at a low-end investment, what if some of your customers' ROI looks like after the fact, after implementing and getting it going?
Well, you know, to simplify it down is, you know, there's some applications you walk in. You could look at it from a standpoint, you know, it's critical to identify defects in some of these parts. You know, there's some companies out there will have a number of people sitting there doing manual inspection because the power of the machine vision system in the past wasn't able to solve it. So if you're able to not only replace manual inspection, but also improve capabilities, which means, you know, people are only as effective as they can be. There's certain studies out there that say that 80% of defects can be found through manual inspection because, you know, people, you know, their minds drift. They're looking at a repetitive action all day long. They don't feel well. They're mad at their boss. There's a number of different reasons. You know, this is kind of why I have a job in this space, is because machine vision has been able to go in and solve applications that are better than machine vision. So, you know, not only are you looking at the cost of you know, replacing manual inspection, but you're also improving the effectiveness of it. It is challenging to use the word ROI and a grand solution. It really depends on the customer. You know, what type of costs are associated with letting past failed parts go out the door to their customers. You know, certain companies, retail companies, will turn around and if you've mislabeled or have not ever sent a defective part, they can come back with fines in the hundreds of thousands of dollars. You know, a lot of the automotive companies, if you're familiar with them, use words like containment. You know, if you send, you know, defective parts to us, you can go into a containment level, which means that you now start getting audited. You have to prove that you're improving your error-proofing functions. So, you know, it's something we work with customers on. And you know, there are sometimes, to be honest with you, you know, we'll talk to customers and we'll say, they'll come up with a list of 10 different defects that they'll want to find, and we'll say, listen, we can do 8 of them. We can't find those other 2. And the customer says, well, you know, if you can't find those other 2, I still have to have manual inspectors on the line, which means I can't get an ROI, a return on investment on this application. So, you know, companies have to look at really the costs associated with making defects and you know, justify. I try to, you know, when my initial meetings with customers is to establish kind of the price point I think applications will take to solve. And from that standpoint, it gives the customer an idea what the cost is going to be to do this, and whether or not they actually want to go forward with testing and quoting and, you know, possibly proof of concept with these applications.
Great, thanks. I think that's helpful. I mean, the first thing everybody wants to know is how much does it cost, and then how much is it going to save me in the long run. So
right.
I know obviously that's going to vary, but just giving an idea of like the areas within their business that they can be looking at for cost savings, that because of this technology that they can say, well, we might have fewer staff members to
right.
do the manual work, or we might, be augmenting the existing equipment that we already have, which allows us to do more and faster. So I think that's good.
I can give you a quick example. I have one customer, it's a web application. We have a number of cameras spread out over the web. We're actually using AI and deep learning. And in the past, their vision system wasn't able to handle a lot of variations and randomness of the surface. So they were left with a vision system that could only find extremely large gross defects on the part. And what would happen is, as the part was, or as the web was running through and is rolling up, if they actually found this defect, what they ended up doing is they ended up throwing out the entire roll, because they weren't going to unwind it down to find it. Their vision system didn't give them that capability. The solution we provided to them allows them to immediately identify where the defect is at a much more reliable. We can do smaller defects at faster speeds, and it allows them to actually stop the line, remove the defect, crip it back together, and actually continue on. So the scrap that they're doing is exponentially less than it was before they put in this type of solution.
And do you see this technology being implemented with in conjunction with like lean initiatives?
I don't think. I mean, well, I mean that's a difficult. I'll be honest with you, it's a difficult question for me to answer, because I think I need more context as far as just lean. Okay.
Well, I don't think I have any more details on that right now, but maybe we'll have some later. We'll come back. One of the other questions we have is, are there any insights or trends you see in vision that may be applicable specifically to mining and aggregates industry?
Mining and aggregates. So, yeah, it's traditionally not been a space with machine vision. It's underground, it's dirty, it's not really the appropriate environment. There are applications. I was involved with one for a mining company. This is about 10 years ago, and we were actually looking at loading on the conveyor. We were actually tracking the load while the material was being put on the conveyor. The conveyors could be, hundreds, if not thousands of meters long. And if the load shifted to one side versus the other, the challenge that you had there was that, you possibly could tip or do a lot of damage with the loading. So we had machine cameras on both ends, or on both sides of the conveyor, tracking the flow of the material on the conveyor. We were dynamically giving a feed loop back through the Rockwell PLC to actually change the loading. So if the load started to shift to the right or to the left and start possibly unbalance the load on the conveyor, we were giving that feedback back to the PLC to change the loading. As far as more in depth in mining and aggregates, I really couldn't speak to it, because I haven't got a lot of experience in that space, other than what I've just mentioned.
Okay. The next question is, deep learning techniques often require millions of sampled and labeled data for training, which might not always be possible or practical to acquire in the manufacturing process. So how would you use deep learning for applications such as inspection with limited labeled data?
See, herein lies the problem. The deep learning, the AI, relies on training based on an image sample set. You need those images to train the system. One of the possible outcomes or approaches to this is to use a very limited sample set, put the system in, install the system, and again, from that you're going to get results from the vision system as it's actually acquiring images and running. and those images would either pass or fail based on the images you've already used to train the system. You can set it up through, there's thresholds that will be this, I mentioned earlier, this confusion area where, you know, it's not quite close to a pass, but it's not quite close to a fail. It goes in this confusion metrics, and you can continuously use those results to take those gray zone images and continually train the system. So you know, the short answer is, would you be able to effectively have a vision solution right out of the gate with a very limited image sample set? Probably not. But if you're willing to grow with the system, you can eventually get to that point. But that's, you know, if you can't feed the system can't learn. You can't,
well, that makes sense.
You know, and I don't know if this is really going to answer the question, but, you know, deep learning AI vision is used quite oftenly in conjunction with traditional vision tools. So you're not limited if you go with deep learning AI, a tool set or the solution. It most commonly is actually used with a lot of other traditional vision tools like edge tools, blob tools, histogram, image processing, OCV, OCR, pattern recognition. So you can supplement that where you know, AI or deep learning may not solve all your applications.
Okay. Our next question is, can the optical system be mobile, checking a static product, or must it be static with the product in motion?
No, actually, it's interesting. I'm working on an application now where, you know, the part is extremely large, aerospace industry, and they want to do automated assembly verification on the part. We've actually proposed a solution using AGV with a collaborative robot, a camera on the end of the collaborative robot that actually moves around the part and actually acquires images. We take those images and we actually run them through the vision solution, the AI deep learning software, because and this is a good point to understand, is because you're not, when you're moving a robot and an AGV around a large part, you're never going to be in the exact same repeatable position. There is going to be some variation in working distances and angle of approach and perspective. The deep learning in the AI can now accommodate for that type of approach and allows us to do those applications a lot more successfully.
That seems very useful with a very large part.
Yeah.
Not have to worry about it being able to process it through something, but having something that can go completely around it and being able to still provide that same level of inspection.
It's a challenging application, but again, the new tools that we're now seeing and playing with and being able to utilize make those applications a lot more feasible than they were 5 years ago.
Good. Our next question is, can deep learning be used to process graphic generated into a PDF file?
Yes. You know, any result from a vision system can be, we've done a number of applications where we're actually overlaying defects onto a 3D model, and from that model we're able to generate a report, an HTML report, and save it as a PDF.
Okay. Our next question is, what are the hardware requirements for a PC and a camera to take advantage of the deep learning?
Right. So the camera in itself doesn't change from deep learning or AI space versus traditional or rules-based vision. You know, it's because you're actually using an extremely powerful software tool, you do need to go with a fairly powerful PC with a GPU PC with some powerful video cards on them to actually create this type of application. When it comes to lighting and optics, that's the same in any vision space. And traditionally what they are is because you're using a PC vision, you're actually approaching this with more GIGI cameras, which are common now, or what they'll call dump cameras, which are out there just acquiring the images, whether they're low resolution, standard resolution. You can get cameras up to 29 megapixels and even larger on the inspection from that standpoint. I've heard rumors that deep learning and AI is going to start making its way into smart cameras soon. It'll obviously, like most smart cameras today, there'll be limitations to the power and the processing that you can do on a smart camera versus a PC. But once that starts making its way into it, you'll start seeing a smart camera with deep learning AI built into it.
So if you're talking about customers maybe over the last couple of years, because obviously the technology's come a long way if you kind of go further back than that, but if you look at when customers are first starting to talk about implementing AI and deep learning with their vision system, and they're talking about hardware requirements, do most customers have a significant technology upgrade that's necessary before they can really start implementing AI? Or are most companies that you talk to already at kind of a standard level of equipment that doesn't necessarily require a significant upgrade?
Yeah, generally speaking, from my experience, and I can speak, really only to, we are a systems integrator. We work with customers on their applications. We estimate costs associated with the solution. We work on them with their functional requirements for the solution. Then we'll deploy a complete system, at which point we'll supply the panel, the PC, the software, the programming, mechanical, cameras, lighting, frames, and deploy it as a system. To utilize existing PC hardware in a facility, you want to dedicate a PC to this type of application using machine vision in general. There's significant amount of processing that goes on. You are going to spend a little bit more money on the hardware on the PC for this standpoint. You're probably looking at a 20% increase in that type of hardware. But outside of the PC and really the software that goes into it, software is good. The two biggest investments are going to be the software and the development time to actually deploy the system. Lighting and optics is generally the same in any application, as long as it's applied directly to that application.
Thanks for that. Our next question is, what are the prerequisites for implementing AI programs in asset maintenance, and what are the main steps?
I'm sorry, can you repeat that?
The question is, what are the prerequisites for implementing AI in assets maintenance, and what are the main steps?
Asset maintenance?
Yep.
So, okay, I'm not sure if I'm going to answer this question correctly, and I'm assuming that they might be talking about the cost or the process to maintain the vision system, and again, it's like any other vision application. It's you can't put a vision system in and forget about it. I did one application one time where it was a somewhat dusty environment, and what we'd asked the customer to do is put an air knife across the front of the camera to prevent particles from dropping onto the lens of the camera. And I guess the maintenance person thought it would be better rather than putting it in front to actually aim the air directly at the lens. And what they ended up doing was actually sandblasting the lens. So, and which was the point where we got a call saying the vision system doesn't work anymore. And, 5 minutes later, we discovered that the camera couldn't see the part that it was inspecting. So, it depends upon, if I'm answering this person's question properly, it really depends on the environment. But, and again, probably the number one thing I want to point out is you can't put a vision system into most factory automation environments and forget about them. There has to be some type of preventive maintenance that's done on these systems.
I asked the individual who submitted the question to maybe give us a little bit more detail, but I haven't heard anything back from them yet. But while we're kind of waiting to see if we do, what are some of your, I guess, best kind of case studies in implementation and like some of the good success stories that you've had maybe within the last year or so that you can kind of share a little bit with people so they can kind of understand, from, soup to nuts, how is it impacting and what was the investment and, maybe just give us a snapshot.
Yeah, so I can point to actually one of the first applications we did with AI and deep learning. As I mentioned earlier in the meeting, we had developed a lighting and optics approach to actually go inside of cylinders to do surface inspection on the inside of cylinders. So we look at the full 360-degree idea of a cylinder. We're able to actually eliminate that and do inspection on it. And there was one application where this particular company applies what's called PTWA, plasma transfer wire. And basically it's a rough coating that they put on the inside of the cylinder. It actually improves and reduces the weight of an automotive engine. Well, because it's a very rough surface on the inside of the diameter, they were looking for voids in what they call spit or large chunks of this that were normally too big or again with the gaps or the voids which was missing. And inevitably after they machined that, what would happen is they get porosity on the inside of the cylinder. So we tried to approach this and solve this, and we were working on this for roughly about 4 years using traditional vision tools. We tried using blob tools, histogram tools, image preprocessing, create our own custom tools, and we were getting 90% of the effectiveness, but because we had difficult times distinguishing with traditional vision tools what was normal surface variation versus a void or a spit, we just couldn't get to that 100%. So over those 3 years, we had gathered hundreds upon hundreds of images. We got our hands on a software solution from Cognex called ViDi, and we took those sample set of images. And what took us 3 or 4 years to work our way up to was solved in about half a day. I can remember the vision tech running around our office trying to show everybody and anybody who would listen to him how this had actually solved it. And it was, and again, this is primarily my approach with customers is that and most of the applications I get involved with is traditional rules-based vision is not effective for a lot of applications that have a lot of variable and random surfaces or features that change just because of standard process variations. They're acceptable, but when you apply vision, which doesn't really reason, it actually for more cases than not, will result in a false failure. I can tell you out of my 23 years now experience in machine vision, most vision systems you'll walk in the door and you'll see on the shop floor that are not working properly or turned off because there's too many false failures. People try to set the tolerances so high to find that one defect or those combination of defects. They end up failing on normal process variations. This new system, because I can now train it those normal process variations, if for no other reason, can dramatically reduce a lot of the false failures, if not all of them, by learning just what the variability on that part or that feature or that surface is. So that's one example of a successful application that we've done. And again, it was very challenging before because we couldn't set the tolerances on the vision tools to not only find that defect, but also falsely identify non-defects.
So can we go back for a second? Because when you said you worked on this project for 3 years and you were obviously increasing, the system got better and better over time, but then you found this one piece of software that was able to really you said within half a day?
Yes.
That it completely kind of closed the gap for you in that amount of time. So that, thinking about how much time went into 3 years worth of work and then be able to really get to the finish line within half a day, that sounds amazing.
Yeah, understand that when we originally were asked to look at the solution by the customer, we came back with, we are going to be, 80 or 85% effective. Some customers, that's not good enough. Other customers will say, listen, it's such a challenging area for us to have human inspectors do it. We'll take 85% over zero any day. And as we, constantly try to improve upon it, so there was an expectation from the customer up front that we wouldn't be able to get 100% effectiveness or 99.999% effectiveness. And then when we were able to get our hands on the deep learning and the VIDI software, because we had the large sample set of images that we have been collecting over the years, it was able to allow us to deploy this solution a lot quicker. And yeah, it really was an eye-opening moment for us.
That's awesome. That just sounds like it really is an area where probably a lot of companies could be improving their overall production and operations, but maybe something that just seems a little unreachable to them, or they don't fully understand the capabilities that AI and that deep learning can really do. Right.
And quickly on the other one was the customer which we're working with, doing the web inspection, and because the surface of the web, the material, had a lot of variable and randomness to it, you can take your hand and rub it over the surface, and you can change the texture of the way it reflected back up, or the image that you got. Is the fact what they had to do is it actually had to blur the lens on the camera so that they actually evened out the surface of the material. Well, the challenge with doing that is you are no longer getting false rejects because of the changing in the surface process variations, but it only allowed them to find extremely large defects, and they lived with that. Ideally, their requirements for defects was 10 times smaller than what they were able to do. We were able to come in and show them that we don't care what the surface looks like as far as the variability and randomness. And we were able to actually train on that and understand it. So now they no longer have to blur out the surface. They can actually directly look at the surface. And they went from something looking for, basically the size of a quarter to now actually in one of the applications was they sprayed or they applied pepper flakes, small black pepper flakes, to it, and we're able to reliably do that. Couldn't do that in the past. Wasn't possible.
That's awesome. Well, it looks like we have one more question here. So it says, nowadays we invest a lot of money to implement inspection programs including vibration, temperature, loads, infrared. and hold on, sorry, it moved on me. But all of these are pieces of data that are collected and analyzed by humans, and the maintenance needs are defined based on that data. So how does AI help with that specifically?
Well, I can answer specifically. You know, machine vision in general can help with that. You know, most people will look at machine vision as it's a good part or a bad part, pass or fail. What people are now, I used to say in the past, what people are failing to realize is what you can get from a vision system, but people are realizing what they can get. What people are realizing now is that within the machine vision space, it is data. And once you get data, you can actually start building statistical models and using that information. You know, one of the simplest forms to understand is that if I'm actually looking at using machine vision and doing dimensional gauging, for example, I can build I can take the results and I can get out of the vision system standard deviation, min, max, and average, and I can actually use that to say, you know what, I'm going to track on my standard deviation, and I should expect to see a sawtooth moving up and down. If it starts to trend in one direction or another towards a failure point, I can actually identify that within the vision system and send an alarm and say, hey, you are now trending towards making a bad part. So the idea is taking all the results from the machine vision, using that information to actually better understand your process and actually identify issues in your process before you make a bad part. So I don't know if it's in general machine vision space, that is a very effective way that people are using this, using machine vision to help their process, understand their process, and hopefully improve upon it. I'm hoping I answered the question correctly.
Thanks, Sean. This is our last question, and then we're going to start wrapping up. It is, can deep learning be applied to 3D images?
No. We haven't. I'll preface this by saying we haven't done it. And the reason for that, so when you're looking at machine vision, it's in any application, it's usually broken up into one of four key areas. One is defect inspection, dimensional gauging, robotic guidance, and identification, OCD, OCR, character verification, reading barcodes. The AI space right now doesn't do dimensional gauging well, so or if at all right now. You can use AI to find a feature or a part that's very challenging to find, and then use traditional machine vision to gauge on it, but you're not actually using machine or AI to gauge on it. So traditionally, if you're looking at a 3D type of application, it's primarily going to be used for a lot of dimensional gauging for height variations, and from that standpoint. So, and right now, you just can't get a 3D point cloud result into an AI software and train on those images. So, in a long-winded way, no, it's not really utilized for AI is not really utilized very well with 3D at this point.
Well, good. That was our last question for today. Sean, I want to thank you for being a part of the session today. And I want to let our audience know that you will be speaking at CMTS as part of our conference program. You're going to be talking about this specific topic, and I believe walking through some more detailed case studies that can kind of illustrate the benefits of this technology. Is that correct?
Yeah. My approach again is excuse the term, not go techno-weenie with AI and deep learning. My approach is really to show applications where, a number of years ago just weren't possible, but that, you know, through the deployment of AI and deep learning, we were able to solve these applications effectively. So a lot of images, a lot of examples showing, you know, the success of machine vision and AI specifically with regards to those applications.
Well, I'm interested in hearing more about it. The presentation is going to be on Wednesday, October 2nd at 2:30 p.m. Again, that's part of our paid conference program at CMTS. We have 3 days of conference programming. The full event is 4 days. And we're going to be having some live AMA sessions at CMTS. So if you sat through this and it was interesting to you to hear about it in like a webinar format, we are finalizing our lineup of experts who will be on site live at CMTS, where you can interact and ask your questions face-to-face. CMTS is coming up this fall, September 30th through October 3rd. It'll be at the International Center in Toronto, and you can learn more at cmts.ca. Again, Sean, thank you for taking the time to answer some of these questions for us, give us a little bit more knowledge and understanding of how AI can be paired with vision applications to really improve, you know, production for businesses. And I'm looking forward to hearing more about it when we get to CMTS.
Great, thank you. And you know, hopefully I've been able to effectively answer the questions. You know, it's a little more challenging in this environment because you can't ask, you know, follow up more detailed questions. But hopefully I did try to answer them to the best of my ability. And yes, if you come out to the CMTS show and the presentation, you know, I'll make sure I'll be able to answer those questions a lot better.
And Sean, if people have questions between now and CMTS, what's the best way to reach you so that they can get those questions answered directly?
You know, the best way would be my email. So I don't know but it's basically Sean, SEAN, .lett at AIS Tech Group, all one word, AISTechGroup.com.
Great. Thank you. Well,
thank you.
On behalf of SME and the CMTS team, thanks, Sean, and thank you to everybody else for attending. I think we've had a great session, and I look forward to the next one coming up.
Appreciate it. Thank you for your time.
Have a great day, everyone.
Have a great day.